In this chapter, we've been creating two mechanical Revit families, a terminal component and a piece of equipment. So far, our focus has been on physical geometry. Why that is crucial, the non-graphical engineering information that defines the mechanical systems in the families is more important. And that's our focus in this video. Open the air terminal you created earlier or detail air terminal in the chapter 2 exercise files folder. So at this point, launch Revit, navigate to the exercise files, and from the chapter 2 folder, open this file, detail air terminal, which I have here open. Then open the default 3D view. From the create ribbon under the connectors panel, you find 5 connector types. Our focus in this course is the duct and pipe connectors. So click duct connector, choose face from the placement options here, which is the default. You can also change the system type from the options bar here, but we'll come to that in a bit. So pick the extrusion end of the neck geometry and select the connector to configure its properties from the properties browser. First, to have shape, which determines the duct shape. We'll go with round. Now I want to match the duct size to the parameter we created earlier. So we'll click the associate family parameter button beside radius and select duct radius. Next, we have flow configuration, which determines how flow values are established for the components in a project. For child components like air terminals, the flow values are preset, which means they'll be imputed by the modeler or designer. Meanwhile, the values are calculated for parent components like equipment. In that case, the sum of the flow values of the child components under the parent are calculated to become the flow value. So this is a child component, so we'll choose presets. Then we'll have flow direction, which determines the direction of airflow in the duct. And this is a supply air terminal, so the air flows in from the equipment. So in this case, we'll choose in. Then we'll have system classification, which determines the mechanical system this connector will belong to within a project. So in this case, we'll choose supply air. Here you can also choose global for components that function in multiple system types like pumps. Then for components connecting different system parts, you can select fitting, but this classification does not affect the airflow. So we'll go with supply air. For loss method, this determines how you calculate components pressure drop. When you choose coefficient, you can specify the loss coefficient within the family environment, or you associate family parameter, which lets you set the value from the project environment. On the other hand, when you choose specific loss, you can set the pressure drop within the family environment or associate family parameter. Lastly, you can also choose not defined. So in this case, we'll select specific loss and we'll associate family parameter with the pressure drop parameter and name it pressure drop. We'll classify it under mechanical and close this. Also, we'll associate family parameter with the flow and we'll name it airflow. We'll make it an instance parameter and categorize it under mechanical flow and close this. Also here you have utility, and this primarily applies to components that serve as a point of connection into a facility. So this is not a point of connection, so we'll leave this unchecked. Finally, you have connector description, and this is helpful when you have multiple connectors of the same system classification in a family. So it helps you differentiate them when creating systems within the project environment. So when necessary, you want to put in short descriptive text within the connector description here. So that's it. We've configured the connector properties for the air terminal, Next, we'll configure the connectors for the equipment. So open the one you created earlier, or detail mechanical equipment, in the chapter 2 exercise files folder. So at this point, you might want to open the exercise files once again, and from the chapter 2 folder, open this file, detail equipment. Then open the default 3D view. First, we will place a duct connector on the placeholder extrusion on the front face of the equipment geometry. Then we will select the connector and associate the height and width parameters to the corresponding parameters we created earlier. So this is a supply duct. So we'll come to height and map this to supply duct height, and map the width to supply duct width. Next, we will set the flow configuration to calculated, which is what we have currently. The flow direction will set to out for supply, and system classification to supply air. The loss method, use specific loss. Now for this flow configuration, you can also set it to system for large systems that have multiple pieces of equipment supplying or returning air to or from the terminal component. So in such scenarios, you must specify a flow factor, which is typically a value between 0 and 1, representing the percentage of airflow in the entire system for which this equipment is responsible for. But in this case, this is not system, we would set it to calculated. Next, we'll associate family parameters with the flow and the pressure drop. So for the pressure drop, we'll call this external static pressure. We'll classify it under mechanical and leave it as type. Then for the flow, we'll call this airflow. Make it instance and classify under mechanical flow. Now we'll close this. So we've defined the properties for this supply duct. Next, we'll create the connector for the return air system. So we'll go to the back, and then we'll place a duct connector on the placeholder extrusion on the back face of the equipment. Then we'll associate the height and width parameters to the corresponding parameters we created earlier. This is return duct height and return duct width. Then we will set the flow configuration to calculated, flow direction to in, system classification to return air. We'll specify the pressure drop. In this case, we use the same parameters we use for the supply air for both the pressure drop and the flow. So now we've defined the two duct connectors. Next, we need to place the pipe connectors to connect the fan coil unit with the central equipment, which are the chiller and boiler. So we need to define these 5 pipe connectors. So to do that, we'll place a pipe connector on the placeholder extrusion on the lower left face of this extrusion here. Now, to change the dimension from diameter to radius, we'll ensure nothing is selected so we can see the family parameters. Then we will set the round connector dimensions to use radius. Now we can select this pipe connector and associate family parameter for radius to the corresponding one. So this is chilled water supply. So we'll choose chilled water supply radius. So in this case, the indoor unit is a child to the outdoor unit for the hydronic system. So we'll set the flow configuration this time to preset. Then we'll set the flow direction in, and then of course define the specific loss. Now, checking this parameter, which is allow slope adjustment, enables Revit to put in small horizontal pipes when sloping pipes connect to the connector. And this is mainly useful for slope systems like sanitary. So we'll get to this later. Now we'll set the system classification to hydronic supply. And then we'll associate family parameters with the flow and pressure drop. In this case, we'll call this chilled water flow. Make it an instance parameter classified under mechanical flow. And then for the pressure drop, we'll call this pressure drop cooling. Type parameter classified under mechanical. And then we'll go to the description and impute a description here. And the reason is because we'll have more than one connector with the same system classification. So we'll call this chilled water supply. So now we'll have to repeat this process for the other pipe connectors. So for each of them, we need to associate the family parameters for the radius to the corresponding parameter. We need to set the flow configuration, the flow direction, and system classification accordingly. So I'll quickly do that. So I'll come here and click on pipe connector. I'll start with this. I'll call this, this is the chilled water return. So I'll map the radius to, this hot water supply. So I'll call this hot water supply radius. And then flow configuration is preset. Direction is in. We'll define loss. This hydronic supply. And then for flow, we'll call this hot water flow instance under mechanical flow. And then this is pressure drop heating, type under mechanical. Then description, hot water supply. The next is the chilled water return, which is this. So I pick this, map it to chilled water return radius. Flow configuration is preset, flow direction is out. Then I'll define loss. This is hydronic return. I will choose the same flow. This is chilled water. And the same pressure drop. This is pressure drop cooling. Then we call this chilled water return. To create for hot water return, map this to hot water return radius. This is presets. This is out. Specific loss. Hydronic return. Hot water flow. Pressure drop heating. Then hot water return. Lastly, for the condensate, to create the pipe connector, map it to condensate pipe radius. This is also preset. This is out. I don't need to define the loss in this case. In this case, this is sanitary. So we need to check this allow slope adjustment. Then we call the flow condensate flow. And this is instance under mechanical flow. Then we don't need to put a description here since we don't have more than one connector with the same system classification. So finally, we need to place an electrical connector because this is an active equipment that needs to be powered. So even though we might not use this within the project, but it's important to add an electrical connector. So we go to create here and select electrical connector and place that anywhere. Unlike duct and pipes, location is not so critical for electrical connectors. So we select this and set the system type to power balanced. And then we need to associate family parameters to the number of poles, the load classification, voltage, and apparent load. And we'll group all of them under electrical. So we'll quickly do that. Number of poles, we call it the same thing. Number of poles, we'll group it under electrical. Then load classification under electrical. Voltage under electrical. And lastly, the apparent load. You can call it load under electrical. So when you finish, you can open the family type dialog and validate that everything is in order. You can even tweak. So you can see we created a whole lot of parameters, some in the previous video, some in this video, and we'll still create some in the next video. So you can tweak these values to make sure that everything works out properly. So that's it. We have configured the connectors and logical systems for the air terminal and the mechanical equipment. So now you can create and modify mechanical Revit families with the correct engineering information.